First of all, what is a client template in server-side GTM? In a nutshell, they are those receiving thingies in server-side GTM. So whenever a request comes to your server-side Google Tag Manager, there are a lot of clients usually, and depending on the endpoint, one or more clients would be ready to process this request. When that happens and a client says, okay, I can understand what's going on here, I can translate that into event data, then a client builds a standard event model, usually from incoming requests. And then on the other side of Google Tag Manager, there are those tags that we all know. One or two or multiple tags might get triggered by the event and then send data out to Google Analytics, Facebook, or whatever. Now, if you're like me, you might wonder, why is there a thing called client living on a server? Google is very, very bad at naming things. And I think this is a perfect example for a very, very, very bad name. I have a theory how that happens. Somebody asked how clients should have been called. And there were many, many good ideas like workers, listeners, endpoints, collectors, sensors, whatever. But then there was the senior dev, and he could give an answer in a fixed font and in dark mode. And he uttered client. Anyway, now we have clients in server-side GTM. This clients is one of the things that differentiates server-side GTM from a regular client-side GTM. You can basically forget about the universal stuff. So there's 3 types of clients that you might find in a regular Google Tag Manager container. To make it even harder to add a new client, they are not part of the community template gallery. Using GA4 requests as an incoming signal for your server-side Google Tag Manager is the way to go if you ask Google. But we can see if there are alternatives available. So this is how event data looks like when a collect request comes in and there's a page view in there. Then the client creates a page view event, and this is all the event data. There are the client hints and all that architecture stuff. And above that, there are things like page location, page referrer, page title, and screen resolution that the browser has sent to your endpoint. The idea is that a page location always has a key called page location, and a page title always has a key page title. So with only these 4 elements of the event model, you could easily feed things like plausible, for example. If you fire a plausible tag, then you don't need much more than only these 4 items. All right, so this is how clients work inside a server-side Google Tag Manager and what they are good for, basically. Then in the next step, let's compare a bit what happens to a GA4 request when it passes a server-side Google Tag Manager. You might ask yourself, will they be the same after passing server-side Google Tag Manager? And the simple answer is no. There are several reasons for that. The most important one is that there are some parameters, incoming parameters, that are only meant for server-side Google Tag Manager to know something about the region and other things, and where to send the request, and the client ID, for example. So usually if you have a server-side Google Tag Manager, you have a server-managed client ID, which means that there is a HTTP-only cookie that only the server can read, and where you have an alternative version of the client ID. That's usually part of the request, of the incoming request, and also lives inside the _GA cookie. So the first difference that is obvious is the other client ID. But there are some other things. Next thing, at least I was asking myself, is what happened if Google adds a new parameter? Because that is basically happening all the time. If I have an old version of the client, for example. So I added a incoming parameter, and what was happening is the outgoing request just repeats this parameter. The way the client works is that when new parameters arise, they are just handed over to the tag, and the tag then adds them to the outgoing request without knowing what they're good for. Google does that with X fields. Whenever there's something that is not part of the basic common event model, something that only your service is caring about, for example, then there are a lot of x minus GA minus something fields. My additional parameter ended up there as well. Okay, now what if you wanted to build your own client template? The first and good news is that building a custom client is quite easy. You don't need to code very much in order to have a proper running and functioning client. So what we want to do is to claim a request whenever it hits an endpoint that we want to listen to, which is hello world in this case. Build a simple event consisting of an event name and a timestamp, and then we run the container, which we do by importing or calling another API, and then we return a response. So it's that easy to build a client that doesn't do very much. But if you think of any proprietary format where you want to send in information, and maybe you want to make it very, very easy for your client to process all those information, then you could think of a client that just takes all the parameters and creates an event model that includes all those parameter keys and values. So if you wanted to build something like that, it's just as easy as this. It's even less code than the first example. This time take another endpoint address like param_demo. We claim the request. We get all the request query parameters using a simple API call. So every query parameter that is incoming will get processed, and we run the container and populating the event model with only these parameters. And this is what happens. If we call the example URL, then the client claims the request and the event data will hold all the information we send in as parameters. If you now think of, well, parameters don't have to be the same name as they have inside the event model, or they don't have to be get parameters, but could be a post payload. Accessing post payload or translating parameters into or changing key names is really trivial. So building your own client that claims your own incoming format is something that you can do in a couple of hours. And if it's not that hard, why are there so many problems when you try to get rid of Google Analytics as a incoming or feeding request format for your server-side Google Tag Manager? Well, first of all, building a custom GA4 client is still easy, because there are APIs for everything. So if you compare this example to the last example, you don't even have to specify the endpoint path or something like that. We just look if the request, the incoming request, includes MPv2 data, which is GA4. So if there is GA4 data in a request, if it is so, we can claim the request, extract all the events with just one line of code, and then run the container again. Doing that would perfectly be enough to have your own GA4 client and get rid of the standard GA4 client. And then you can do all those additional stuff that you want to do before you run the container, for example. But if you want to have something incoming that is not GA4, then it gets problematic, because replacing GA4 requests is not easy. And that's because the browser controls everything when it comes to GA4. The browser knows when a session starts. It knows how much sessions there were before. So it knows if there's a new user. It controls the end of the session. And the parameters constantly change. And there's consent mode additionally. So if there's something new, GTag knows what to do, but you usually don't know what to do. So running GA4 on a non-GA4 request stream is not very pleasant. Because look at GA4 data. It looks like every other event data on the first side. But if you look at the details, then there's the GA session ID, which has to be a timestamp. And the session number, of course. You have to count sessions. GA4 is the only tool where you have to count sessions in the browser. Every other tool counts the sessions on the server. That's really a problem. Then there are all those server-side tracking system properties where nobody really knows what they're good for. You can try to mimic that stuff, but you have to keep an eye on real incoming requests, and if there are any changes, and if there are, then you have to develop changes in your own client again. And then there are all those GA proprietary X fields. Your options are limited. You can live with some constraints, like you can feed GA4 with incoming requests from something else, but dimensions will be missing or some metrics will be misleading. And first of all, you can't share it with your Google Ads account without lying about consent mode and all that stuff. So do not expect data to be suitable for advertising. The next point or the next option would be to mimic GTag in the browser and use a standard GA4 client. But mimicking GTag in the browser is not easy, as I already told you now. You can use alternatives like WalkerOS, and you can use all of those clients in order to receive requests, in some ways limited. So if you do not use GA4 at all, your options get broader and you can use all of those other incoming requests. So my advice would be to use custom clients for any other tool, any other task. So here are some examples. You can use it to proxy, a tackless request proxy, for example. You can use alternative GA4 clients. You can use Snowplow or Pivot Pro analytics data clients that already exist out there. You can build any APIs if you want to. You can call cloud functions from your server and loop through the response, for example, in order to make your cloud functions first party. And there are alternative clients out there. As they are not part of the gallery, you have to look them up for yourself on GitHub and on GitHub Gist. It is interesting. There are good ideas, and maybe you can use one of those templates in order to find your own starting point if you want to build something that can receive your own requests, for example. I would like to thank you, and please connect with me on LinkedIn. There is a unofficial manual, as I called it, about how to build Google Tag Manager custom templates.